Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, this time we're going to use this Nobsound 6P1 to show you how to work with an oscilloscope. And this is a video that I've had a lot of people asking me to do, and I want to go kind of in detail about how to hook up an oscilloscope, how to, what to look for when you're buying an oscilloscope, like the kind of leads you need to get, getting a signal generator so that you can get some useful data from the oscilloscope on tube audio gear, and some of the safety stuff that I feel is important to use with an oscilloscope. And at the same time, I can show you how I used an oscilloscope to find the initial problem with this amp and how I knew that I had fixed it, which this is a perfect product to show you like the testing methodology on modifying an amplifier using just an oscilloscope. And since I have the audio analyzer suite, I can go deeper in than I was when I first worked on that, but let's not get sidetracked. So one of the first things I want to go over is the isolation transformer. And yeah, there's dolly hair all over it. But anyway, somebody wrote in a week ago or so was saying, hey, on your scope, can't you just ground the chassis to the oscilloscope ground, and then you don't have to worry about the chassis ground floating? And I'm telling you guys, the easiest way to work on this gear safely is to buy an isolation transformer. We're not talking about a ton of money. You can pick one up for less than $100. And this is a little one I got off Amazon. Make sure that there's some of these things out there called isolation transformers that are made for hospitals that have the ground still pass through, and that defeats the whole purpose of what we're doing here. Even if you lift the ground using like a 2-prong to 3-prong adapter, that doesn't isolate the neutral from the ground if the ground still passes through. So you want to use a true isolation transformer or modify one of those hospital grade ones to, an audio test bench style isolation transformer. There's plenty of videos and content. I'll try to see if I can find a website to put in the description down below that goes into more detail about how to make sure you're getting one of these. But if you have one of these, you don't have to worry about getting the grounds crossed up with a hot and burning up your oscilloscope. And you could have an amplifier that you're testing that it's gotten wired up wrong, or maybe was wired wrong from the factory and has the hot and the neutral reversed, or some other mess that if you don't have the neutral isolated from the ground. And like real quickly, what I'm talking about, in the US, the neutral and the ground are tied together in the fuse panel, and then that's hooked to earth. And by using the isolation transformer, you break the connection between the neutral and the ground, because you always want the scope grounded using the 3-prong plug. And that way, this whole circuit is floating free of the ground. I mean, not only does it help keep you from shorting out and frying your expensive oscilloscope, it also helps protect you from shock by not having a ground potential through your body. I'm not saying you can just stick your finger in here and poke around and you're not going to get shocked. You're still going to get shocked. But it helps keep you from possibly getting shocked if you touch a positive with one finger with no path to ground. So it helps keep you safer, it keeps your equipment safer, and given how simple I'm trying to keep all of these series and ideas, I'm not going to go into how to, create a ground for the chassis to ground to the ground lug on the oscilloscope. But then when you're voltage testing, you do need one of these anyway. So just use one of these. It makes life a whole lot simpler, and it keeps you from even having to think about it. The other thing you're going to need is some dummy loads, and these are 8 ohm, and I forget what wattage these are. I think these are 20 watts. Wait, here it is right here. 100 watts. So these are 8 ohms and 100 watt loads. You'll never need anything bigger than this working on tube gear. I mean, even if we build some, push-pull KT88 monoblocks, they're not going to be over this. And so get a pair of these, and then I tin the ends on these. I strip off about an inch and then tin it. Twist the wires together and tin it, and that way you can put it on the speaker jack and still have a place to hook up your oscilloscope. You never want to power up a tube amp with nothing hooked to the speaker outputs for any reason, even when there's no signal going in, because if there's some sort of oscillation going on inside the amp that you're not aware of, may be out of audible range, it needs a load hook to it, or the voltage will spike in the output transformers and arc, and once the arcs through the insulation in the output transformers, they're toast. So bottom line, never power up a tube amp without speakers or dummy loads or something that's the right ohm rating connected across the output jacks. So next, we're going to jump into the scope and the probes and the signal generator. Okay, here's the gear that I use, and obviously there's modern gear that could replace this old analog style gear, but I've had this stuff for a long time, back before they had all the new digital oscilloscopes, and I've personally never used one. I know they work really well for this kind of stuff, and it makes this so much more affordable than it used to be. These things, when they were new, were super expensive, especially relative to the dollars in those days. But now you can buy these fairly reasonably, but they're starting to get pretty old. And luckily, I've never had to do any repair work on these, but I know, I've seen videos online about people having to replace the caps in them and do all kinds of stuff. And honestly, there's a couple of parts of this that are getting a little bit wonky, but I'm not interested in going inside this quite yet. This is an old Tektronix 2235. It's a 100 millihertz scope. It's got 2 channels. Got nice triggering. Never had any issues with working with tube gear on it. And it's just been a workhorse of a scope that I've had, like I said, for a long time. Recently, I bought this little Tenma signal generator. It's a 1 megahertz. I like it because it's got like this knob on the front. It's got some buttons here for changing the different ranges. And then down here, it's got a knob that you can adjust the voltage. And then it's got an attenuation in steps for the different ranges. And so it also will drive a pretty heavy load. I've run it into the 8 ohm outputs of a output transformer and had no problem driving into that. And I'm not sure, what the newer signal generators will drive into, but there's also workarounds for that. If you wanted to, check the turns ratio on an output transformer, you could just put the signal into the high impedance side and measure what's on the 8 ohm side with the scope. And so I wouldn't, let that drive your decision. I think a lot of the modern digital scopes have a signal generator built in, which would eliminate having to have 2 pieces of gear. But then you've got menus and, like I said, I like just having a knob or a knob and being able to adjust things with individual knobs instead of jumping through menus and pushing buttons. But it's up to you. How would you want to go on this? Whichever kind of scope you're going to use, you need a pair of leads because we want to measure the signal going in, which is what's coming out of the signal generator, and then we want to be able to measure what's coming out, whether we're measuring across the dummy load on the output of the amp or whether we're measuring some point inside the amplifier like the grid of the output tube, so we can either diagnose a problem as far as no signal at all, or being able to figure out where the distortion is coming from in the amplifier, whether it's coming from the driver section of the amp or the output section of the amp. Because until you know that, you don't know which part of the amplifier you need to be working on or modifying. So again, you're going to need 2 probes. These are just some eBay, they don't, I think they're 100 megahertz just like this scope is. You don't need, the gigahertz stuff that's crazy expensive because we're never going into frequencies anywhere near that. Even a 1 megahertz scope would be high enough. But when you get into scopes that are that low a megahertz, you're getting into some really old scopes like those old, round screen ones. Yeah, you don't want to get into that mess. Then you're starting to work with antique gear. So this is about as old as I would get. Some of the newer versions of this have some very nice features where they'll show on the screen the volts RMS and the frequency and that kind of stuff, which this one's a little either older or a cheaper model that didn't have that. Those are kind of nice features if you're not going to spend a lot more money on. I would get one that, don't buy one that they're saying, no guarantee or no returns or it powers on and that's all we know. Spend the money to get one that's been tested if you're going to buy one of these older scopes, or go ahead and buy a new one. And there's plenty of other YouTube channels that talk about the digital scopes. I'm not going to talk about them because I don't know anything about them. I've never used them. This is what I know. And so, anyway, next thing we're going to do is we're going to get everything set up and hook this up to the amp. I'll show you how I make all the connections. We're going to move the camera around so you can get a little better view on all that. And then we'll go ahead and run through doing some tests on this little Nobsound 6P1 and start showing where its flaws are and trying to figure out where they come from. Okay, so let's go over some of the basic controls that we're going to be dealing with. A lot of these controls we don't have to mess with. Like these little red knobs, don't have to touch them. These 3 knobs, I just keep them all the way to the left. You can tune these a little bit if you're having trouble getting a trigger, and I'll explain what that is in a minute. This seems to work good over on A. This controls the seconds per division, which is the width of the waves as they're displayed on the screen. This does the vertical of one channel, and this does the vertical of the other channel. So let's turn the scope on, and every scope I've used has a calibration port. And it's very useful when you're kind of getting a feel for what the controls on the oscilloscope do. So here's our probes, and we've pulled this little thing that has the clip. It just pulls off the end of the probe. So we're going to pull the tip off of both of the probes. We're going to connect both of them up to the 2 ports. The B and C connector on the front of the oscilloscope, and it is good to note that the outside of these connectors is connected to the safety ground. And so these are grounded to your house. So good to understand that. That's one of the reasons that we are using an isolation transformer to make sure that we're never putting voltage that has a connection to earth that could possibly be connected to this ground and end up with a short and sparks and bad stuff happens. So anyway, this control here does left channel, right channel. This knob here goes up and down to adjust the vertical on channel 1. This adjusts the vertical on channel 2. I usually leave this on alt, but if the screen gets real pulsy, you can flip it over to chop, and that sometimes helps kind of smooth out the display. But as you can see, it's a little brighter when it's on alt. I leave the horizontal mode in A. As you can see, it gets dimmer and then disappears. So we just leave it on A. On this side over here, these all stay flipped up to channel 1 for the trigger, A for the source, and AC on this last flip up switch down here. We're not going to be using the external trigger, and I'll go over what some of these other things do, but we're not messing with most of this stuff. Also leave this in P2P auto for the trigger, and I'll show you what the trigger does in just a minute. Okay, so we've got both channels enabled. This is the intensity of the beam, and you just want it as bright as it needs to be to get a crisp line. If you turn it up too blinding, see how it gets real fat, and it's, you potentially could burn the screen. So you just want that just bright enough where you can see the line good, like that. And then the focus does exactly what it says. You just turn it back and forth until you get it as crisp a line as you can get. And that looks pretty crispy right there. Okay, so now we're going to use our little probe adjust port. We're triggering off channel 1, and this is 500 millivolts peak to peak at 1 kilohertz square wave. And there it is. So we're at a half a volt per division. We pull this down. You can see it's exactly on 1 division, so it's calibrated well. If you flip this down to 1 volt, we lost our trigger. And there we go. And I just play with these knobs till I get the trigger back. When it starts doing that, starts doing weird stuff like this, it's just scrolling. It means it's not this. It needs a little more strength on the trigger. This little button here will change the slope that it picks up the trigger on, either the up or the down slope. So it just doesn't really matter which one you use. And again, you want to just make sure that this is triggering like it's supposed to, and that you're seeing this half a volt. So the next thing that we want to check is there's a 10x multiplier on these probes. So when we flip it to 10x, we then need to turn it till we get our divisions back, and we're back to we've moved the half a volt over to the 10x probe part of the knob, so we know that we've got our 10x setting. So the other thing that you want to do while it's on the 10x setting is you want to adjust the probe, especially if the square wave isn't nice and square. And you just put the screwdriver in this hole in the probe, and as you turn it, you'll see the square wave getting unsquare. And you just turn this little screw on the probe. See there, it's skewing that way. It's skewing that way, and you turn it until you get a nice flat square wave on the top. So now we're going to check our other probe. We put this in, and man, it's just scrolling like crazy. Well, we got to tell the oscilloscope we want to trigger off channel 2. So we flip this down to channel 2. Now it's triggering off this channel. Go ahead and adjust this probe. And it's not a bad idea just to get in the habit of adjusting the probes before you start working with an amp. Just to make sure that your probes are calibrated to the channel that they're on and that you've got a nice good reading. And again, you can have one channel, the other channel. You can pick which channel you're going to use to trigger. I normally use channel 1, and then I connect channel 1 up to the signal generator, and then I use channel 2 as my measuring the amplifier signal when I'm looking for the waveform inside or externally on the amp. So I think that kind of goes over the controls, how to basically set it up. And like I said, this test board here will help you get familiar with the controls and getting it all set up. And luckily, we're going to be using a 1K hertz signal for our testing. 99% of the time, that's what we're going to be using. And so we know that this is a 1K. So we get the waveform looking right on the screen using the test port with this 0.5 volt per division, and then we can adjust things from there. So let's go ahead and get the amp all ready to hook everything up to and start testing some signals in our amp. Okay, so this was a little tricky getting this all on our screen, but I think I've got it where I can show you how to do a very basic power output of the amplifier. So first thing we want to do is turn on our signal generator, and we have it times 100 on 10, and as you notice we have the same pattern that we had for 1 kilohertz, which was like 2 peaks across the screen, except this time we've got a sine wave, which is what we use for doing general testing of an amplifier. The other thing I didn't show you is you can move horizontally with this knob over here on this side, which I usually leave it right on the center, but sometimes it's helpful when you want to use these finer graduations to put the peak on one of these finer graduations to read like single-digit volts coming out of the amp. So anyway, first thing we want to do is we want to get 3 volts peak to peak coming out of the signal generator. And this upper line here is the signal generator output that's coming into channel 1. So we're going to turn this up until we get 3 volts peak to peak coming out of our signal generator. And I've found that this simulates what a normal line signal is coming out of a DAC or something like that, really close. And so it gives you a good idea of the signal strength you're going to get out of the amplifier putting this signal in. So one of the things I also do is once I've found my 3 volts peak to peak, I turn this down to 2 volts and move this up here to the top of the screen to kind of get it out of our way. So the next thing we want to do is we're going to take our probe from channel 2 and we're going to connect it up to the output of the amplifier. And this is going across our dummy load. We're on the right channel, and this RCA jack is soldered to a couple of wires that go over to our signal generator. So now we come over here and we start turning up the volume control on the amplifier. And normally I set this on 5 volts peak to peak. But on this amp we may use a lower voltage, and there's clipping. You can see right there the way this bottom half is just hard clipping. That's what I call hard clipping. And so we know that's like really heavy distortion. But right there is what this amp's putting out. And like I said, sometimes it's helpful to, we're going to set the top peak on that middle line, and then we're going to move this over so it's easier to measure with these little graduations. And it looks like it's putting out 11 volts peak to peak into an 8 ohm load. And I'll do the calculations and put that in the bubble over this video. But that's not a lot of power. The other thing that's helpful to do is get about the same size wavelength and put these kind of on top of each other and look at them. That'll give you a good idea of how much distortion you have. If you see them wildly different, like this is real skinny and that one's real fat, you're seeing a ton of distortion. So even though this thing's not making a lot of power, I'm not seeing a ton of distortion, which is why these amps sound pretty decent if you've got some really efficient speakers and you're only using like the first little watt or so of the amp. So that's basically what I wanted to accomplish on this video. Let's wrap this up. Well, I hope you all have enjoyed this video showing you how to use the basics of an oscilloscope and a signal generator with a tube amplifier, how to connect things up, how to be safe. And I mean, this is one of the best ways if you've got just like a dead amplifier of figuring out what's dead. Is the coupling cap open? Is the output tube dead? Is the driver tube dead? Is there something wrong with the potentiometer? You can figure out all of that stuff using a signal generator and a scope. And it will also tell you how much power the amplifier makes, and you'll learn to be able to see what distortion looks like and clipping, and then how to make changes to an amp after studying the schematic, and then being able to test to see if the modifications that you've made actually did what you thought they should. So I hope you're enjoying my channel. If you are, please subscribe, please like the video, and we'll see you soon for more tube audio fun. Have a great day.